Hello friends, welcome back to some awesome science with me. My name is Dr. Erica and I am so glad that you are joining us today to explore the wonderful world of science. We are in our Indiana Jones unit, so if you love Indiana Jones, it'll be right up your alley. And today I have a very curious question, because in Indiana Jones there is a scene where he has this golden idol. It's really cute. You see it from the back. It's got two little bum cheeks and like the hair coming back. And he's gone through all of these booby traps to make it to this golden idol that he wants to research. And he's gonna take the golden idol and place a bag of sand on it and hope that that works. And we're gonna find out today whether it works or not according to science. And we have two projects to do. One of them will be doing a little bit of weighing and some fun back of the envelope calculations to learn about density. And then the other one, we're gonna actually make a density column. And I have a fun little project because I have some real pennies and some fake pennies, and we can actually use the density column to tell us which one is which will be fun. So if you are joining us, the things that we are using today, for the first part, you might not have these on hand if you're just joining us, but that's okay. You can just join along. I have a bag of sand. I tried to make it about the size that Indiana Jones has in the movie. So I have a bag of sand about that size. And then I needed a heavy weight for my golden idol. So I just have this kettlebell here. I won't be lifting it up and weighing it on the kitchen scale, but it weighs a little bit more than 30 pounds for this little guy. And that's gonna be our sort of pretend golden idol for the moment. And then for the density column, you just need a bunch of different liquids. You could have different ones than I have, and I'll teach you guys how to know what order to put your liquids in. But just to give you an example, I have some honey. Molasses is a great one for honey too. I have some dish soap. I have some canola oil, and I have a bit of water. And then you just need some sort of glass that's sort of skinny and tall so that you can create your layers. And these layers that we're going to create is going to become a ruler for us. It's going to be like the way we can measure certain items. So it's kind of a unique and different ruler that we have. All right, so I do want to remind you, if you're just joining us, make sure you click subscribe on our YouTube channel. Give us a thumbs up. Spread our message. We are here Monday through Wednesday with live science classes at 1 o'clock Pacific time. And our units are going to be 2 weeks long, and every other week we are going to have a field trip. So when we do our weather unit, we're actually going to go to the National Weather Center, and we have a contact there, and she's going to join us live in Zoom after we get to go on our field trip to the National Weather Center, so you guys can ask her all of your weather-related questions. And we have some very cool 360 experiences that we're going to plan to do for our archaeology, and I'm working on talking to an archaeologist to get them to join us live in Zoom too. So if you have some archaeology questions, you should email them to me at drerica@rosieresearch.com, because next Wednesday we'll be on a field trip and hopefully we'll have a live archaeologist with us to talk to us. And again, if you have something you would love to study, make sure that you fill out our survey or email me at drerica@rosieresearch.com, because we are planning things far in advance and I'm super excited. We have a whole chemistry week or unit, so 2 weeks coming up, and it's going to be a lot of fun. We've got weather coming up. We've got an oceanic week coming up, so I can't wait to learn all these things with you. All right, so let's see what happens in Indiana Jones. Will he trigger the trap, or will he be safe? Will this bag of sand be enough to replace the golden idol? Now, if I look at them, this guy's a little big, but I think the golden idol's maybe a little bit skinnier. I mean, size-wise, they're not crazy. It's not too bad. So size-wise, we might be able to trick this trap. But let's think about things other than size. And you might think of it right now as I'm moving things out of the way. And that is the weight of each item. So even though these are sort of around the same size, we need to check their weights. I know this is about 30 pounds. So I'm gonna weigh this one right here. And we do have a new camera here, my friends. So bear with us as we try this new camera idea. So I'm gonna turn, my scale on. And it's just a regular kitchen scale. This is just beach sand. Ah. All right, we are gonna weigh it. And it's looking like it is 2 pounds and 10 ounces. I'm feeling really generous. We're gonna say that's 3 pounds, even though it's slightly over 2.5. We're gonna say that's 3 pounds. Now, you might tell me, Dr. Erica, this one's bigger, but I'm gonna write down the weight of my Ziploc bag in this box right here. I'm gonna write down 3 pounds. So if we put this guy, I guess we can put this over here. I'm gonna put it at 3 pounds is the weight of that Ziploc bag. Now you might say, Dr. Erica, this one's bigger. And I could be like, all right, do you think it's 10 times bigger? Because 10 of these bags of sand is actually the same amount of weight as this iron kettlebell. All right, so, I don't know about that. But here is the other question. That golden idol is gold. So here we go. This right here is just a typical pencil case that we got for our girls starting school. This is shockingly similar to the size of a gold bar. All right? If this were pure gold, this would weigh 27.5 pounds. So now we're gonna do a really fun little piece of math. These are my favorite kind of math. It's called a back of the envelope calculation. And I just wanna tell you, when you do back of the envelope, you can't be wrong, all right? It's like you're just trying to get into the ballpark. You're not even trying to get a right answer. And these ones can teach you so much stuff. They're my favorite. I took a class in graduate school all about back in the envelope calculations. And you might be like, Dr. Erica, whatever. Who cares if it's a ballpark? It's not accurate. It can't help you. But let me tell you this. Back in World War II, there was a guy who got non-classified images of the atomic bomb because Time magazine had published the images of the atomic bomb. No other information about it, just the pictures. And they showed the picture of the atomic bomb when it was being dropped, and then 5 seconds later, and then 10 seconds later, and they showed sort of a time-lapse series of maybe 4 or 5 images of the atomic bomb going off, all right? And at this time, the atomic bomb was any news about it was very, very hush-hush. Any actual information about it, other than what it looked like, was highly classified, all right? There was a guy who looked at those pictures and said, I actually know the energy of the atomic bomb. I know how big that bomb is. And he was right within a factor of 2. And government agents showed up at his doorstep to see how he knew this highly classified information, all right? So he did that on the back of an envelope. How cool is that? You can also estimate things like how many piano tuners are in the city of Chicago, or if I went to a Seahawks game, how much mustard does the Seahawks people need for all of those hot dogs? You can do that all with back of the envelope calculations. And we're gonna do one today because I wanna know, would this actually work? So this is 27.5 pounds. And in my back of the envelope calculation, I'm gonna make a guess about how many of these gold bars I think are in this golden idol picture. So it's about this tall, the golden idol. It's a little bit kind of round and fat. So I'm gonna guess that maybe it's sort of 2 together. Maybe more than 2, but I think I'm gonna go with 2. You might say, Dr. Erica, I think it's just 1. Cool. You can do your calculation with 1. You might say, Dr. Erica, I'm pretty sure it's more than that. I think it's 3. Awesome. I love it when you guys try something different, all right? So you go with what you think is reasonable. I'm gonna say I think 2 seems reasonable. So I'm gonna say we need 2 gold bars to make that golden idol. And then I'm gonna multiply it by 27.5. Whew, that's gonna be what? 55 pounds. My golden idol weighs 55 pounds. Whoa, team. That is not anywhere near this 3-pound bag of sand. Nowhere near it. And in fact, in the movie, the trap also knows this because the trap realizes, hey, this is not the same weight that was pushing me down. And then he gets chased out with a huge boulder that starts going down inside of a tube. It's very exciting. So even the trap knew that this was not possible. But that might get you wondering because in the movie, he sort of swaps them and he just grabs the golden idol with his hands. I don't have hands like that. Evan is super duper strong. He's super duper strong. Pretty sure he does not have hands where he could pick up something like this with 55 pounds. In fact, you might watch every movie differently now that you know this, because when people are just like handing over gold bars, those are really heavy. Like, I couldn't just, this is like the weight of a gold bar. I can't just like hand this over willy-nilly. I have to work for that. That's pretty cool.
Just a side
Yeah.
note.
Side note.
55 pounds of gold is worth $1.6 million.
Woo! Now we all want that golden idol. That is a lot of money. Wait, how much? 56 million?
No, 1.6 million.
1.6 million. A lot different, but in my world, still kind of the same. That is awesome. So the other question is, what do you think? Was Indiana's bag of sand close to the weight of the golden idol? I think I'm going to go for a resounding no. Not even close. I'm even going to put a sad face on it. Now here's the other thing that could be true though. Maybe in the movie, the golden idol is fake. Maybe it's not gold. Now here's something interesting. In fact, this happened a lot way back in history. People would say, I want a gold crown. And someone would go make them their beautiful gold crown. And then they'd be like, wait, but is this really gold? And they would have to wonder if it was really gold, right? And people would be like, well, there's no way you can find out. It looks gold. It's gold on the outside. Who knows if it's wood on the inside? Well, we could actually find out if it's wood on the inside, or if it's air on the inside, or if it's fake gold. We could find that out. And the way we can do that is by making a density column, which is cool. This really happened. Somebody tried to cheat a king out of his gold crown, and Archimedes, who was a scientist, was like, wait, we can test that. They did it a little different than what we're going to do today, but I think the way that we're going to do it is a little bit cooler. So the way we're going to do it is with a density column. Now I have 2 pennies here, all right? And if I was a really good smith way back in history, I might have been able to make these 2 pennies and try to pass them both off as whatever pennies that they are, how much ever worth they were. But maybe I made a whole crown and it was like really expensive, and I was like, yes, it's totally made out of just pennies. And somebody might be like, wow, how did she do that for that price? Like, I mean, really? Just the pennies alone. So we're gonna find out. We can look at which one of these is real and which one of these is fake by using a density column. All right, so to make my density column, I am going to line up my liquids in their densities. So density is like the weight per a certain amount. So if I took a cup of honey, how much would a cup of honey weigh versus a cup of vegetable oil versus a cup of water versus a cup of oil? Now, if you have different items and you're like, Dr. Erica, I have something different, how do I know which to go first? I actually have a list on your guys' printouts right here, and it tells you the densities of a lot of things you might find in your house. So maybe you're using maple syrup or milk, mayonnaise is on here, olive oil's on there, acetone, like nail polish remover, is all on here. So you could choose, and you could do them all. You could do as many as you want, all right? So you can make a 2-layer density column with just water and oil, but you could also make 3 or 4 or 5 layers, however you want, all right? And we are gonna make 4 layers, and I am going to set it out. So honey is my most dense. It weighs 1.42 grams for every little milliliter, which is like not very much, it's like this much. Then I have dish soap, which is, I think, 1.06. Water is 1, and the oil is gonna be, let's see, probably about a 0.85. So I'm just ordering my numbers from big, 1.42, to small, 0.85. All right, so if you're using different liquids, you're gonna wanna shift around which way you're going. And we're gonna put our most dense liquid, the one that's the heaviest for that one little unit that we're gonna measure out, we're gonna put that in first, so that goes at the bottom. So for me, that is some honey. Sort of a tragedy that we are gonna put some honey into the science experiment because I love honey, but it must be done. So here we go, we're gonna add some honey, it's coming down into our jar.
Delicious.
It looks delicious. It looks like it would go perfect with breakfast on some buttered toast.
Not after the Ajax.
Yes, soon it won't look good. Right now, Ooh, it's making silly sounds. Right now I'm like, who needs that? Let's just take this over and eat it up. All right, I'm gonna add enough where we can see the different layers, because what we're gonna do to learn about which penny is real and fake is we are actually going to drop them into our density column and use that as a ruler. This is really thick honey. Goodness. All right. So there is my honey. And next I'm going to put some, I'm going to put my soap in, because that is my next most dense item. So thankfully I already have things that are pretty clearly different colors, but you could add some food dye if you wanted to. So I'm going to stream it down the edge just so that I don't mix them up. I want to not mix things up if possible. I'm going to get like some nice layering here. And that's how we're going to use our ruler. All right. So let's see. Let's make it go a little faster. And you can see how it's making 2 layers, which is really cool. All right, that's probably enough dish soap for us. And you can see the difference between the honey and the dish soap. I mean, I guess they're both orange. It would have been great if I used maybe a blue dish soap. But we can see that we have those 2 layers. So now I'm going to add in some water. And again, with the water, I don't want to just splash it in, because I kind of want it to slide down and lay on top. I don't want to mix them together. So I'm just going to add really slowly some water. So let's just add that nice and slow. Oops, I'm going a little fast here. But we'll do our best so that we don't mix the 2 up. Or if we're mixing them, we want to mix them as little as possible. Okay? All right. Let's see, is that enough? So you can kind of see it. As I tilt it, you can see them all sort of shift.
Lift it up just a little bit.
Yeah. So you can see that we've got our honey and our dish soap and our water. I think I might try to add a little bit more water so I have more in my water layer. So I'm going to just really gently shift it and add a little bit more. There we go. That's probably good. All right. And so now as it's coming down, you can really see we've got the honey, the dish soap, the water, and the last one I'm going to do is the oil here. Although I do have some rubbing alcohol, which I think will go on top of the oil if we wanted to make a 5th one. But now the oil, you'll know that water and oil don't like each other, so the oil is actually a little easier. I still like to pour it nice and slow, but we do know that it's going to come straight to the top of the water. Those will separate for us. All right, so I have honey that comes like right up to there. I have my dish soap, my water, and I have some oil. It's looking a little funky because we poured it in and there's a little bit of water mixed into it right now, but that will sort of separate out. All right, so this is our new ruler. And what we can do with our ruler is we can drop items in to learn about their densities. So the more dense it is, the more it will sink down into our column. The less dense it is, the more it will float on different layers. So I could take a little pop cap and I could drop that in and we could look at what happens. And it looks like, ooh, it's hanging out on top of my honey. And we'll see if over time maybe it will actually end up going into the honey. Maybe it's slowly going in, which is what it kind of looks like. It looks like it's not sitting on top of the honey. I have a little teeny tiny Lego right here. I could take a little Lego and I could put that in. Ooh, interesting. The Lego is right on top of that oil. That surprises me. Although it's like a little boat right now. So maybe let's see if we fill it with oil. There we go. Kind of like a little boat. It does look like it's floating on top of the water, however. All right, we'll put it right up there. I have a little teeny tiny styrofoam ball, so we can plop that in. Let's see where that guy goes. That one looks like it's floating on the oil. Oh, interesting. When I moved it, I've got my little Lego fell through the water. It looks like it's not quite floating on top of the soap. It's kind of in there though, we'll see. I noticed that my pot lid is now sinking into the honey, so it's more dense than the honey. But you see how I can separate these things? So now I can take out my real and my fake penny, and I can see if my density column will separate the two. Because if it does, it will tell me whether or not what I give the king is real or fake. So I can drop one penny in. I'm gonna just I don't wanna drop it all the way. There we go. Ooh, that one went straight down. It is already being consumed by the honey. All right, so it is all the way in there. And I can drop this one in. Interesting. Ooh, it doesn't even make it through the water. Look at that. Oh, it is. But it's much slower. Look at how differently this is falling through our density column than the other penny, which is already all the way down. All right, now Evan is gonna give me a real penny, a known real penny, and we will drop our real penny in. It's a little bit chipped, but that's okay, because density doesn't matter how much of something you have, it's an inherent quantity. So it's like, even if I have less, the density is still gonna make it sink. So let's watch a real penny, and we can learn if this one is real or fake. All right, so let's drop this real penny in. Ooh. That went so fast, didn't it? And it is already being consumed by the honey, where this fake penny is not. Evan's telling me to switch it around, but you can't even see it. It's like already in there. It is inside that penny all the way, which is pretty neat. So we can use density to determine if something's real or fake. Here we did it for a real penny or a fake penny. We have done this with our girls in terms of a real chocolate coin or a fake chocolate coin, which is really cool. We learned about density during St. Patrick's Day as we sorted the leprechaun's mischievous fake gold, which happened to be wood covered in gold foil. I mean, that was very tricky of them. And the real deal, when they caught the real leprechauns, they got chocolate ones. And we were able to use a density column to determine which one was which is pretty cool. And that is our project for today with Indiana Jones. So we learned that, no way, Jose, there is not a chance that this bag of sand that I can hold up and pass to somebody is anywhere near the true weight of that golden idol. And we also learned Hollywood was probably totally faking their prop. That was not a real golden idol, because I cannot pick this up and go run through a tunnel with it while being chased by a giant boulder. I can't even, I couldn't even put this in my pocket right now. It's not even happening. So that we can learn by density. And even if somebody's trying to fool you and says, these are true gold earrings, you can make a density column and you could figure out if what they're showing you is real or fake, which is pretty cool. I am going to say goodbye to my YouTube friends unless anybody has put any questions in the chat for us, and we'll say hello to our Zoom friends. If you want to get into our Zoom room, you are more than welcome to join us. You can always support us, which gives you access to the Zoom room at patreon.com/RosieResearch, and don't forget to subscribe so that you get notifications every time we go live. All right, my friends, we will see you tomorrow as we continue on Indiana Jones with the Staff of Ra, and we will learn why it's really important for Indiana to use the staff in a specific spot at a specific day and time of the year. And I cannot wait to show you guys that. It'll be a fun little project that you guys can make and watch over the course of the day and even over the course of the year if you want to. All right, we'll see you tomorrow and have a great afternoon. Bye, friends.